Okay, in this video, we're going to have a look at what we call reaction pathways, and then I'm going to give you an example to illustrate it as well. So reaction pathway is basically the route that a reaction will take to form a particular product. So let me give you an example of what I mean. So we could have chemical A and chemical B reacting together to make chemical C. But it could also be possible to take two completely different chemicals, for example, chemical D and chemical E, and also get those to make chemical C. One of these routes could be better for the reasons we're going to look at in a second, and therefore that route would be chosen as a way of making chemical C. So the factors that we have to consider are linked to a lot of the learning that we have completed previously. So the first factor that, or not the first factor, but one of the factors we look at is the atom economy for a reaction. Remember, that is looking at the amount of chemical, the amount of reactants that ends up in the desired product. And obviously we want as much of the reactants to end up in that desired product, and that way we are limiting our waste and being more efficient. The next factor we look at is the percentage yield, which you have had a go at calculating. And again, that looks at trying to maximize the amount of reactants that end up in the useful product, which then reduces waste. That links in with using our resources wisely, so we're not wasting those resources as well. Next on there, we have got the rate of a reaction. So reactions can work at different speeds. That could be affected by factors like temperature and pressure, and that will add extra cost to the process. If we've got to use high temperature, then there's energy costs. Higher pressure, it costs money to create those higher pressures. Another factor to consider is the equilibrium position. So again, if we go back to our work on Le Chatelier's principle, we know that we can change an equilibrium position, but that requires changing conditions. And if we want to make a reaction go in the forward direction to produce the product, then we may have to heat it up or cool it down, which all have cost and energy implications for us to make decisions on. Let me just check my notes to see if there's anything else to mention to you there. I think that is some of the key features that we need. So if we're doing this, there's a question here that says, what does it mean if we have something that has a high percentage yield but a low atom economy? Well, if we have a reaction that has a high percentage yield, that means that we are turning our reactants into the useful product. So that would be a good thing. A low atom economy, so a low atom economy means that the sum of the chemical that we're starting with is ended up not in a useful product, not in a desired product, and therefore is being wasted. So that wouldn't necessarily be the most favorable option you would take if you were making a decision about a reaction pathway. We've mentioned that some of these are going to make waste products, and the problem with waste products are you have to dispose of them. So disposal, issues around disposal: one, it costs money. Two, we could have chemicals that are toxic, harmful to the environment, and that makes it challenging to dispose of them. The other issue around this as well is that sometimes we're using reactants that are finite, they are limited, and we don't want to waste those resources. We want to make sure that as much of those resources end up in a useful product, and if we have waste products, then that's definitely potentially creating the waste that we don't want. In the next bit, we're going to look at an example of this using the production of ethanol